Good morning. Hope you have all gone through the last classes of laser. In the last class, we have discussed about laser as an introduction and discussed what is induced absorption, spontaneous emission, etc. Now we will move on to the next topic, that is stimulated emission. So you have already seen what is induced absorption and spontaneous emission. Now the next topic is stimulated emission. For this process to occur, the atom should be already in the excited states. So usually all the atoms will be in the ground state at a normal temperature, and when it gets an energy by the absorption of photon, it gets excited to the higher energy level. So for the stimulated emission process, the atom should be in the excited state, already in the excited state by absorbing some energy. Let a photon having energy h nu is equal to E2 minus E1. That is the energy difference of these two energy levels. Interact with an atom in the excited state. Suppose one atom is already excited to this excited state by absorbing some energy, and if another photon comes and interact with the photons in this excited state, such interaction, the incident photon stimulates the excited atom in the level E2 to transmits to the lower energy level E1, resulting in the emission of a photon of energy. So what's happening? This excited atom is stimulated by another photon of energy h nu, which is equal to the energy difference of this excited and ground state energy level, and so that excited atom emits extra energy in an enhanced manner. This process is known as stimulated emission. Okay. So the photon is said to stimulate or induce the excited atom to emit a photon of energy h nu. The passing of photon does not disappear, and in addition to it, there is a second photon which is emitted by the excited atom. Thus two photons are released, each of energy h nu. So at the end, what happens? Two photons are emitted by the absorption of this photon. That is, the atoms were in the ground state, and it is excited to the higher energy by the absorption of h nu. Okay, at this stage, an photon coming and interacts with this excited energy state atom, and which causes an emission of its extra energy and the absorbed energy now, and so two photons are emitted. So this process is known as stimulated emission. So these photons stimulate the emission of radiation by this atom. That's why it's known as stimulated emission. So but the spontaneous emission occurs naturally. It does not need any external photon to trigger this emission. So that's the difference between spontaneous emission and stimulated emission. Okay, so here I have shown these three processes together in a single picture. This is induced absorption. Here the ground state atom absorbs a photon of energy h nu and get excited to the higher energy level. This is induced absorption. and the spontaneous emission is the excited state atoms cannot stay for a long time in the excited energy level. It naturally tend to come to its ground level to reduce its energy and become stable. So that's its extra energy, that is the E2 minus E1 is emitted back as h nu and come down to the ground state. This is known as spontaneous emission. And in stimulated emission process, what happens is the excited atom is stimulated by an incident photon of energy h nu, which is equal to E2 minus E1, and it emits 2 photon of each of energy h nu. So that is the 3 process. Okay. Now what are the different characteristics of stimulated emission? So the stimulated emission process is controllable from outside. This is said to be controllable from outside because this process is initiated by external photons. External photons triggers or stimulate this process. That's why it can be controlled from outside. And the second one is induced photon propagates in the same direction as that of the stimulating photon. Both the induced photon and inducing photons are propagates in the same direction. And the third one is induced photon has features identical to that of the inducing photon. That is, their frequency, phase and plane of polarization are same. So both will have the same features. And the last one and the most important one is light amplification. All the light waves generated in the medium are due to one initial wave, and all of the waves are in phase. Thus the waves are coherent and interface constructively. The light emitted through stimulated emission is of very high intensity, and we say light is amplified. So what happens? So in the previous point, we have seen that the induced photon and inducing photons will have same features like frequency, phase and plane of polarization. So since these waves, the emitted waves, at the end we have seen 2 photons are emitted. In the previous picture I will show you. Yes, at this end 2 photons are emitted. So each will have same phase and same plane of polarization, etc. So what will happen is these 2 waves interfere constructively. So what will happen? This intensity will be increased, or the waves get amplified when it interfere constructively. So we will get an amplified light in the output. So stimulated emission causes a very high intensity light wave which is amplified. So this is this peculiar process is happening in lasers. So that's how light amplification is taking place in lasers, and so and that's why it's known as light amplification by stimulated emission of radiation. Okay, so stimulus happens by the incident photon, and by getting stimulated by the incident photon, it produces a high intensity and amplified light at the output. That's why it's known as light. That's why it's produced amplified light, and that's why the name laser. Okay, now it comes meaningful to the name laser. Now we should know some important terms related to lasers. These are very important when we study laser, because this should be learned before start learning the working principle or the theory of laser. So first one is population. This time we have already explained in the first class, on the first session. that is the number of atoms per unit volume of a medium that occupy a given energy level is called the population of that layer. And we have discussed it in the last class. That is usually a material medium consists of same atoms having energy levels, and many of the atoms is confined to same energy levels, and the number of atoms per unit volume of a medium that occupy a given energy level is called as the population of that particular level. And another important term related to this laser is metastable state. What is metastable state? You may have heard about stable state, unstable state, and what should be the metastable state? A state occupying in between stable and unstable state. Okay. So usually an atom stays in an excited state for only 10 to the power minus 9 second. That is of the order of nanosecond. 10 to the power minus 9 means nano order. So 10 to the power minus 9 seconds. Since this is very short time, the excited atoms immediately returns back to the lower energy state. But in certain materials of particles, there exist energy states in which an atom can stay for as long as 10 to the power minus 3 seconds. Such excited state in which an atom has longer lifetime than in normal excited states are called metastable states. So let's go back to the previous figure. So we were discussing a material medium consisting of only two energy levels, E1 and E2 for simplicity. So let's explain this metastable with this. So when an atom, usually all the atoms should be or will be in the ground state at normal temperature. But whenever it gets some energy, it gets excited to this higher energy state E2. Okay. Now at this energy state, at the high energy state, these atoms are unstable. That is, it cannot stay at this energy state for a long time. The lifetime of this excited atom here is of the order of 10 to the power minus 9 second. Of the order of nanosecond. So what will happen? It's a very short time, so that these atoms will get de-excited and will come back to this original ground state by emitting extra energy as radiation. So that's how this spontaneous emission happens. So this is because of this very short lifetime at this excited energy state. Now in some materials there are some possibilities or there are some chances of these excited atoms to come in between a certain energy level, somewhere here or somewhere here or somewhere here, that is a level in between this in the stable state and unstable energy state. So this excited state atoms can come to this energy level somewhere in between these two energy levels, and where it can stay for some more time rather than the lifetime at this excited state of the order of 10 to the power minus 3 seconds. So 10 to the power minus 3 seconds is larger than compared to 10 to the power minus 9 seconds. Okay, so that this atom can, the excited state atom can come down, and instead of coming down to the ground state, it can come down to this energy intermediate energy level state, where it can stay for a long lifetime rather compared to that of this excited state, and that state is known as metastable state, and which is very important in order to explain the theory of lasers. So this metastable state should be there in order to occupy the lasing action. So why this metastable is important in lasers? For the lasing action to take place should be understood by understanding the another term, population inversion. So it should be clear why metastable state is important in laser by understanding the term population inversion. So what is population inversion? Usually in a medium, most of the atoms will be in the ground state and only a few atoms will be in the excited states. But if a system has a metastable state, then it is possible to create a situation in which there are more atoms in the higher energy level than in the ground state. This condition is called population inversion. So what's explaining here? Let's go back to this picture. That is, at normal temperature, majority of the atoms will be, or most of the, or almost all the atoms will be at the ground state. Okay. If it does not get any energy, it doesn't receive any energy from outside, all the atoms will be at the ground state. Okay. So the population, so we have already explained what is population, energy per unit volume at a particular energy level. So the population at the ground state will be more compared to the excited state when this is at the normal temperature. Okay. Now, so these are at the normal population levels. Now what happens when an energy absorbed by these electrons at the atoms at the ground state, it get excited, and due to this short lifetime, this will come back to this original ground state, so that this population should be maintained like that. That is, even though the atoms are getting excited to the excited energy state by the absorption of photon, it gets de-excited spontaneously to the ground state without any delay, because the lifetime is very short here. So the population should be just as like that of normal temperature. So in order to taking place the stimulated emission, which is the process of production of amplified light at the output, which is happening in laser, the population inversion should happen. Population inversion means the population at the excited energy level should be more compared to the ground state. Then only the stimulated emission process will occur, and hence an amplified light will get at the output. That's what we needed in lasers. So in order to obtain an amplified light at the output in the laser, stimulated emission should take place. For stimulated emission to take place, there should be more population at the higher energy level or excited energy level compared to the ground state energy level, and this is a reverse situation from the normal situation, and so this process is known as, or this situation is known as population inversion. That is, more population, more number of atoms at the excited level compared to the ground state level. So at this stage this cannot be happen, and this can be because whenever the atoms at the ground state are excited to the high energy level, it will get de-excited soon, so the population inversion can never be achieved. So how it can be achieved? It can be achieved with the metastable state. That's why metastable state is very important in this laser action. So what happens if a material is possibly having metastable state? In such materials, what happen? Whenever electrons are get excited to the excited energy level, it will come to a metastable state. So the metastable state is having more lifetime compared to the excited energy level, so that it can stay there for a long time compared to this excited state. So for some time this population inversion can be achieved between this ground state and this population metastable state. So population inversion can be achieved with this metastable state and ground state, and at that stage the stimulated, we trigger the stimulated emission process, and that's how we produce amplified light at the output. That's why the metastable state is important in laser, for lasing action to take place, and hence the population inversion. So these are the important terms connected with laser. So the metastable state and population inversion population inversion are the necessary conditions that should be achieved by the material medium in order for the lasing action to take place. Okay, so next we will explain the working principle of laser. So I will start with this. Okay, for example, so what is in general, so we are considering here the energy levels here, like this is ground state energy level. Okay, and these are two excited state energy level for simplicity we say. And what happens, the electrons may get excited to the atoms get excited to the excited energy state by absorbing some energy. And here you can see a term pumping. So I will explain it soon, what is pumping. So by pumping mechanism, these electrons will get excited to this excited state, and since the lifetime is very short here, it will de-excite by fast decay to this energy level, and this is the metastable state. And here a population inversion is occurring between E1 and E0. So this is the metastable energy state, this is the excited energy state from so a population inversion is achieved by this E1 and E0. So what happens if we induce these atoms in this level by inducing photons to this medium? Lasing action takes place, that is amplified high intensity light can be produced from this. So this is how a laser works. So we will discuss specific examples of laser, like solid laser and gas laser. Ruby laser is an example for solid laser, and helium neon laser is an example for gas laser. So we will explain these lasers in the next class. Okay, thank you.